for lesson 3. Let's kind of review what we talked about yesterday. If I have how would I do that? How would I do that? Do you remember how we did that yesterday? 3 divided by 5. Okay, 3. So you're going to draw 3 boxes because I have the number 3. So I have 3 whole boxes, and I'm going to divide them into how many parts each? 5? How do I write that as a unit now? What do I need to do? Glad we're reviewing. Samantha? How'd you know that? Okay, and each one of these is worth how much? How much is each of these little boxes worth? If I were to color in one right now, how much would it be worth? A fifth. So how many total fifths do I have? So I have 15 fifths. So in this case, 3 is the same as 15 fifths. You see how that works? So I don't need the 3 anymore because I now have 15 fifths. And what am I dividing by? 5. 15 divided by 5 is 3. But don't forget your label. 3 what? Also known as 3 fifths. How would I know? Let's look at this. How could I just look at the division problem and know automatically that it's going to be 15 fifths? What do you think? Turn and talk to your neighbor, quickly. What do you think?
5 times 3 is 15, and you already have 5.
Okay. Okay, time's up. How can I look without drawing pictures? Because I don't want to spend my whole life drawing pictures. The goal is to save a tree, not kill more. What can I do? Madison? Okay, if you look at it, if you take this number right here, these 2 numbers, and multiply, but if I'm dividing by 5, what's it going to go on top of? What's your 15 going to go on top of? Five. This fraction right here, divide by 3 divided by 5. How would I make that as a fraction right now, just by looking at it? 3 fifths. And I had that upside down earlier, I think. I had that upside down. Okay, so let's see. How'd you know that? What have we always talked about with fractions? A fraction is also known as a division problem. Remember the top number, the numerator, where does the numerator go when you divide? Where does it belong? Okay, but when I divide, where does it belong? Nope. On the inside. And the denominator goes on the outside. So, then you ask yourself, how many times does 5 go into 3? And then you'll end up with a fraction of 3 fifths again. So today, look at your problem set. I'm going to go through B with you. I like this because they kind of mix it up on you. 3 divided by 2. What would that be in unit form? In unit form. What do you think? What did we talk about earlier? When you have the two numbers, if you don't want to draw the picture, what could you do?
You could set the two numbers and on both of them, it's 3 times 2, so you get the common denominator, right?
So I could take the two numbers that I'm dividing, multiply them. So 3 times 2 is 6 halves. Divide by a minute. 2/3. What am I dividing by? 2. Equals, what is 6 divided by 2? 3 halves. Now, Mr. Dewey showed you a minute ago how to take an improper fraction and make it into a mixed number, right? Right? So what kind of fraction am I going to end up with here? What number is going to go on top?
Since you did improper fraction,
Well, what do I do first? Tell me what the fraction is going to look like.
it's going to look like 3 halves, which is 2 on the denominator.
Okay, so your first box looks like this. Your second one looks like this. Your third one, you're telling me, what are you going to do?
Since you did improper fraction,
But you need the fraction first. What's the fraction going to be?
3 halves.
Okay, so we end up with 3 halves. Because didn't we just write that equals 3 halves? Yep. And then now what do we do?
And then since you add 2 plus 1, which is 3, you change the 3 to 1, and then you get, and then put 1 for mixed number.
Okay, so you ask yourself, how many times does 2 go into 3? How many times, everybody? 1, remainder. 1, remainder, 1. So what I tell people is 1, remainder, 1. And then the number we're dividing by is 2. So that would be your mixed number. And today they've added one more step to this. How do you think we're going to solve it using standard algorithm? Divide it. Now, we've already said that a fraction is the same as a division problem. What number goes in the box? The numerator or denominator? What one goes outside the box? Okay, so it's going to look like this. 3 divided by 2. How many times does 2 go into 3? 2 times 1 is 2 minus 1. And you take your remainder. And you look at your, what is that number called? It's not your numerator anymore. It's your, no. Camden? It's your divisor. It's the numbers going into it. Your divisor now goes on the bottom here. So does 1 1/2 match with this? Yes. How do you think I would check that? How would I check that? How would I check it? If I had, I don't know. Let's say I have, how would I check that problem? How would I check it? Chance? Okay, you multiply your, what's that called in division?
Your quotient?
Your quotient by your divisor. So 2 times 50. Does this match this? Yeah. Yeah, so that's how you know if you're right. So thinking about that, how am I going to check to make sure I did my division correctly? What do you think? Multiply. What am I going to multiply by? Want to help him out? 2. 2 times what?
1 1/2.
Okay, so you need to make sure your papers look like this, guys. 2 times 1 and 1/2. And when I multiply times 2, couldn't I say it's the same as 1/2 plus 1 1/2 plus 1 1/2? Because I'm taking this number 2 times. Now what do you think I do? Okay, so first I start my whole numbers. 1 plus 1 is 2. 1/2 plus 1/2 is a whole, or 2 over 2, right? Can that be reduced? What happens now, Brianna? That equals 3. Did I get the same number as what's inside the box? Yeah, that means that I did it correctly. This is part of your homework. You have to check your work. Need to find one. Let me see. Everybody have that written down? Copied? Yes, ma'am. Yes. Yep, you always want to reduce. Now that you guys know how to reduce, you need to reduce. Some of them, though, you're going to have to work backwards. Everybody has this? Okay. Some of them you're going to have to work backwards. Let's say I have and I need to know what that looks like as an improper fraction. Does anyone have any idea how to do that? Because today you're going to have to work backwards to make improper fractions.
1 equals 2 half, so you add 1.2.
Okay, so you're saying that this 1 would be the same as 2 over 2?
Yeah.
So you're saying take 1/2 plus 2 over 2 would equal, what would it equal? Okay, 3 over 2, which is an improper fraction. There's another way to do it, though, where you're not going to be, like, if you have, like, 7 and a half, that'd be a lot of adding. So anyone know of another way?
You do 2 times 1 plus 1.
Okay. If the adding works, though, for you, I always say, whatever works for you, do it. I just try to introduce you to different ways to do things, okay? The other way that you can solve this and turn it into an improper fraction, you would take, I'm going to spread it out a little so you can see this, because you need to write this somewhere on your green paper, okay? Because I'm going to take this mixed number, I'm going to turn it into an improper fraction. Make sure you leave enough space between it to write. Your first step is to take 2 times the 1. So, of course I'm going to run out of room. Denominator times whole number. And then add the numerator. For an event, the trays are placed in warming boxes for delivery. Each box can hold 5 trays of food. So we're trying to put 16 trays into boxes, right? So let's start by drawing our boxes. Now, if you want to use the methods that you've learned today, you can. If you're struggling, I try to show you guys the easiest way you can do things. Okay, so I just made boxes. And how many does each one show or hold? Each one holds 5 trays, right? So if you're completely clueless on what we've been doing today, you can approach it from this viewpoint. Because sometimes word problems throw you guys off, but once you start drawing pictures, it's like, oh yeah, I get it, right? I may have too many boxes right now. I may not have enough. I don't know because I haven't figured it out yet, but I know a way to figure it out that is pretty simple. So how many trays do I have? I have 5 boxes. Well, I don't have 5 boxes. I have 5 slots in each box, but how many trays do I have? How many trays? Look at the problem. Huh? 16. So I'm going to take my 16 trays and I'm going to go And the reason I'm drawing this out is because it seems these types of problems really throw you guys off. If it says how many days will be left or how much will they need to buy, and you're not quite sure because you have a remainder, we can just look at it. We can visualize right now how many boxes will the caterer need?
4.
Why did you say 4?
All filled up, and he still has only one in the other box, but he still needs it because he didn't do it all. He just doesn't have it.
Good. You can't, it doesn't say, let's break a box apart. Okay, let's cram the extra tray in with the other one. And this, you guys have been getting thrown off with these types of word problems if you don't draw the picture, because I get answers like, well, he needs 3. And then you forget about the 16th one. He actually needs 4 boxes. On B, it says, if the caterer, make sure you've drawn this, my pen is off. That's how you would explain it. He will need 4 boxes because he needs a place to put the 16th tray. Can't just carry it. Might spill it all over himself. If it was me, I would spill it all over myself. And then on B it says, if the caterer fills a box completely before filling the next box, what fraction of the last box will be empty? So we've done that, right? We've filled every box. So what fraction of the last box is empty? Not full, but empty. Does that make more sense, though, when you draw the pictures and you can actually see it? I think so. I think the pictures help me a lot. And even that way, if you're not good at multiplying and dividing, draw them and you have it all right there.